Hello, I'm Professor Rad, and today we're going to visualize what it means to multiply fractions. So in the next video, we'll go ahead and we'll establish, the technique and the rules for multiplying fractions. But in this video, we're just going to visualize it to help us understand where that rule comes from in the future. So what we're going to do is we're going to visualize what it means to multiply 2/5 by 3/4. Now, ordinarily, multiplication means repeated addition, but how would you add something 3/4 or 2/5 of a time? That doesn't really make sense. So instead, I like to think of this multiplication when you have like a fraction times an amount. I like to think of that as the word of. So for example, if you wanted to find half of 8, half of 8 is going to be represented mathematically as 1/2 times 8. So if we were to say, well, what's half of 8? That kind of means take 8 divided by 2, and you get a smaller amount, 4. So 1/2 times 8 is 4. So let's visualize what 2/5 of 3/4 is going to look like. In this case, I'm going to start out with 2/5 as my drawing. So I'm going to draw a rectangle to represent the whole, and then I'm going to break that up into fifths. So something along that lines. And then for 2/5, we're going to shade in 2 of these squares. All right, cool. Okay, now we're going to take 3/4 of that 2/5. So what that means is pretend like these blue lines aren't here, and I'm going to take this filled in green region. Okay, so this is the only thing that exists right now, and I want to take 3/4 of that. So again, I'm going to ignore that line kind of down the center, and I'm going to split that up into quarters this way. And just for completeness sake, I'm just going to extend that line, each of those lines I drew, and we'll see why we might want to do that later. And so I've broken this up into 1, 2, 3, 4 rectangles, and we want 3 of those rectangles. So I'm going to color in now in this like orangey color 3 of those rectangles we just made. So that's 1, 2, 3 of those rectangles. So 3/4 of 2/5 is going to be these little greenish orangey sections here, orangey greenish sections. So when I get my final answer, I need to refer back to the original drawing. Now, when I drew these lines for quarters, I intentionally extended them just so that we could refer back to this separation for the whole shape. When I look at this whole shape and I take those fifths that we were originally broken into and then count in those lines that I drew for quarters, we've now broken up the big shape into lots of little, like, I don't know, they kind of look like playing cards here. So let's see how many of those pieces there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our new pieces in the whole shape, we can think of it as being broken into 20. And those size pieces, we had 1, 2, 3, 4, 5, 6. So we had 6 of those in the end. So 2/5 of 3/4 or 3/4 of 2/5 is going to be 6/20. And of course we could simplify that and stuff, but this is the visual breakdown of that multiplication problem. Notice that when we did that, if I refer back to the original fractions, a way I could think about getting that 20 is by doing 5 times 4. To get 20. And the reason that happens is because we're taking those fifths that we had, and in order to take what we had and make those fourths, we split it up into 4 going this way. So it's kind of like we have 5 going across and 4 rows, and 5 times 4 is 20. Then a similar kind of thing happens in the top. 2 times 3 is 6, because again, we had those 2 columns of green, and each of them, there were 3 in each of those columns because we were finding 3/4. So the top was also 2 times 3. So one of the things that's kind of weird about multiplying fractions is that it's very different from addition. In addition, we need to keep the same size of our piece because we're counting sort of the accumulation. But for multiplication, what the multiplication ends up doing is it ends up breaking some pieces into different sizes. And so you end up just multiplying the tops and the bottoms. Both the top and the bottom is going to change in multiplication. So you don't need a common size piece. We didn't need common denominators to multiply. And both the top and the bottom change. So that's something you want to bear in mind when you're going back and forth between multiplying and adding. They're going to have a very different set of rules. So in the next video, we'll apply those rules to find some products. And in the meantime, I hope you have a wonderful day. Bye for now, everyone.